Welcome everyone to another interesting problem which is titled as binary tree level order traversal. So let's try to understand the problem statement. You will be given a binary tree and the construction of the binary tree is such that we can access information level by level. For example, the level at which the root exists is a one level, and upcoming the next levels as you can see highlighted, and the third level. So level by level you just need to access those value and you have to put it in a list. As you can see in the first level the list have only the value 3, and in the second level the list have values 9 and 20, and in the third level even though initially 2 are empty, it doesn't matter, fine, the remaining is 15 and 7, and all this list should be a member of another list. So the output would seems like something like this: a list which contain list. Those inner lists are nothing but the level elements which represented inside another list. So this is the output. So how can we get this output given a root of a binary tree? So we can use the key idea of breadth first search method, BFS. So it would be ideal to explain the dry run along with the already written code. So this is the code as you can see, and I am going to dry run this particular example with the given code. So as you can see, the method inside the class is nothing but have the root is given, which is nothing but the optional node, and I am supposed to return a list of list as the problem statement demanded. So I am going to start like root is passed, if not root. If the root is empty, we just need to simply return an empty list. Nothing could be done. And I am going to start with initializing a empty list, which is result. We can see how we are going to populate this particular list with many inner list inside it. That's going to happen. And I'm going to initialize a queue data structure, and at the beginning I'm going to store the node root. I could have done it a bit differently. For example, I could have done q equal to dq, then I could have append q dot append root. I could have done something like this also. It's fine. This particular step, skip the two steps and return in a single line. And let's see. So initially the root is the one element in the queue. I'm going to check while queue. Yes, the queue is non-empty because this particular element is been occupied, and I'm going to initialize level. This level is nothing but the inner list. Inner list is what we are going to populate. Inner list means list like this. Okay. After some point, this inner list will be going to append with the outer list. So this is going to happen. So let's get another information. Nothing but level size is nothing but length of queue. Initially it is just 1, and we are going to iterate for dash in range of level size, nothing but 1. So this will happen one time iteration. So why we have used queue data structure? The answer to that question comes in this particular step, because we can do pop left. For example, if a list like first in first out can be implemented in an order of 1 time complexity in a queue data structure. So we can use this pop left function. It's an inbuilt function we can use in this particular data structure. That's why we are going to utilize. So what we are going to do, we are going to assign the node. Initially, first step it would be the root, because root is the only element which exists, and that's the first element, and the root will be node now, and level dot append node dot value. The root dot value is nothing but 3. So the level would now become 3. And next what is going to do? The queue is already empty. Then we are going to populate with if node dot left. Yes, node dot left is there. Then q dot append. Then q, this thing becomes node dot left. That is nothing but the node 9. And node dot right. Yes, that's also there, as you can see here. Then that is 20. That node is also going to append. And at the end, the result, initially it is empty. That list will be appended with level. Initial level is nothing but 3. So this has already appended. Okay. And this control sequence will go here again. While q, yes, q right now is nothing but the node 9 and node 20 exist in the queue. And again the level initialized to an empty. Level size, right now it will become 2. Then the for loop will happens twice. Then first the node will become 9. Okay. Then level dot append node dot value. So the level will take the form 9 will initially come, and it will check if node dot left. Here in 9's case there is node dot left. In right case also node dot left is not there. So these two things will not happen in the case, but it will happen. It will iterate again because it's 2 right now. And here again node q dot pop dot left. Here it is will be 20, and it will again check 20th case. Yes, the q will be populated with its left, that is 15, and its right, that is 7. Okay, and this for loop terminates, and it will again ask result dot append 11. So the result right now will become list 3. Another list which is we have populated in level, that is nothing but 9 and 20, will also attend. And again it will go while q. Here in q right now there are 2 elements. Again it will happen to have 2 times. Here since there is no following child nodes, okay, simply these two stuff will not happen here, but this pop dot left will happen for first for 15, then for 7, and this will be like combined and represented in the level, and this level will again attach to the result, and at the end there is no further q. So once this is done, we will get a list of list result like this, and at the end we would return the result. So this is what actually happening here. So, and the question is, what is the time complexity? The time complexity, since we are visiting each node once, the time complexity would be order of n, and the space complexity, there is q and result we are going to store here. So this and this will make order of n as well. So I hope you understood the problem of binary tree level order traversal. This is different with the post order pre-order traversal we have, or in order traversal we have already seen. And thank you for listening.